All right, today we have an interesting one called Operator from OpenAI. Operator is the name of an agent system that looks like ChatGPT. Simple little chat window that you type into and say, please go buy me some tickets to the concert this weekend. And it opens up a cloud browser, not one on your desktop, and controls it. It reads what's on that browser, it takes actions for you, and then when it comes to a point where it needs to log in or take information from you or something like that, or even scenarios that it might not be sure what to do next, just like ChatGPT, it asks you a question back, kind of saying, hey, I am stuck here, or can you come help? Or would you mind taking over? Or do you mind giving me your date of birth? That's kind of what this system's all about. It's pretty exciting. Its accuracy is higher than things we've seen, and it really is that beginning. This is the actual beginning, I believe, of the agent story that we're going to see this year. I expect by this time next year, we will be in a place that is very difficult to imagine today, and this is going to represent that very first step. Let's take a look. Okay, so this is the Operator description page. You currently can only use it with a ChatGPT Pro model. So this is the $200 a month subscription. It's not for Plus users that are the $20 a month. It's still under their Pro model. It's a research preview, as they describe it. One of these things that they say they're going to be gathering information, I'm sure, training on how people are using the systems, what's working and what's not working. The expectation is this will start coming to the Plus users, which are the $20 a month, and then maybe even general users before we know it. I would expect this year to be filled with these kinds of agent kind of releases. So this is really just the beginning. It's very exciting because not only is it the beginning, but for some of the things that it's doing, some of the things that people are asking it to do in the first examples, booking tables for dinner or an Airbnb, those kinds of things, buying tickets, all of that is really quite successful. Even OpenAI is saying, don't expect real success from this. This is kind of their sample video on the launch page here, that you can see what it's doing. When they put in the information, put in a request, just feels like ChatGPT. What it does is opens a small browser window essentially within the page that you can watch what it's doing. What's happening behind the scenes, this is a browser that's actually in the cloud. So you can go away from this and come back later if you like. And it's also, because of that, secure. It's not looking, doesn't have any access to the information on your system. So that's kind of an interesting way to go as well. But what you're seeing here is the system underneath takes pictures, screenshots of each one of the states, and does an evaluation on that screenshot to figure out how to take the next step moving forward. It's using some of the kind of thinking processes that we've gotten used to with some of these o1, o3 kind of models and DeepSeek and other things. So it's really trying to use a little bit of the agent kind of based thinking that we're starting to get used to. They say it's a GPT-4o image model, but also a new model that they've released for this. So let's talk about the new model for a second. Their new model is something called CUA, Computer Using Agent. And you can see here they say it's a universal interface for AI to interact with the digital world. And what they mean by that is really an agent that was trained on people using the internet. And in fact, of course, if an AI agent can use a browser, it can do a heck of a lot because we do so much in our world these days on the web. So it's really a great place to say we don't need APIs that are specific for computer-to-computer communication, since we've already built this human-to-computer interface called the web. And that really is essentially a version of an API. It's how do you make Amazon work? How do you make Airbnb work? It's the way you use that system. And it uses the system in very much the same way. So this system is really designed to use the web at this point. It uses other things. We'll get into the numbers in a second, some really interesting things that they shared. But its real purpose is to be something that you'd be able to put a prompt into that can then go and take action for you. Interestingly, a lot of what it does is wait for user feedback in certain scenarios. So if it gets to a place that it is about to send an email, it actually, very much like ChatGPT, will send a message back to the user saying, do you want me to send this email? Please review it. Other places, it requires that the user is watching the entire time that they're using some web system. If they get to particularly private areas or sensitive areas, they require the user to be fully engaged and watching what's going on and validating it all the way. In some places it's completely automated, which is really very cool. So, but the nice idea of it using the web, of course, ungates a whole bunch of things as they get better, which they will only get better at being able to use as many web systems as possible. And I would imagine as we see more of this, web systems start to enable themselves to be more easily used by these systems as well. So all of a sudden it becomes something that if your system is set up this way, it's much easier for an agent to use, and thus agents start using it. You would expect those kinds of behaviors would start leaking themselves into design rationale. So looking back at our numbers, you can see one of the interesting things that they did share is they kind of put some metrics together. So they put benchmarks around how good they are at using computer systems as well as web systems. And there's two different systems here that they're kind of talking about. Web Voyager is one, and OS World, which is kind of all multiple different operating systems, Windows, Linux, and Mac operating systems that they are running known tests against and being evaluated against. And they have a 38.1 success rate on OS World, and I'll show you in a table before how it compares to humans, and 60 to maybe 85, 90% success rate in Web Arena, Web Voyager tasks. So that's very interesting. I'm glad that they have some benchmarks around it. It's something that obviously we're going to have to watch going forward. But if you scroll down and take a look, their general construct, and you'll see this in a second because we get to see some examples on this website. They have a really good example system of how it flows through. You'll get to see the screenshots. Is it obviously does perception? This is not surprising. This is how we kind of do the web as well. You know, they use a screenshot to perceive what they're seeing. Then they send that through some reasoner to say, okay, is this going to get me closer to, or am I finding the next step that I was looking for? And then once they figure that out, they get measurement systems and say at this XY position, do a click and then do a type, those kinds of things. But if we look down here, interesting, the numbers above that we were seeing, their success rates is in computer use, they're seeing a 38% success rate. So they're passing 38%, and a human is at 72%, which is really saying something. We should be a heck of a lot higher. Our OSs should be easier to use, which I know we all agree. But previous state of the art, which would really very likely be the Claude release, the Anthropic release of computer use. On Web Arena, they're at 58% and 87%, where humans are at 78%. So there's a lot of opportunity here, a lot of growth before it reaches our level of capacity to use these systems. But you would expect, like we've seen with AI and everything else, they're going to gap that very, very quickly. All right, so here's some very cool examples of them using the system. So let's do a total refund that someone wants to take. They enter in this prompt, and you can see it's going down the different screenshots that it took on the left over here. It's waiting for a second after it makes a click, then it takes another screenshot. It looks for the cancel order. It looks for its particular order that it wants to cancel. It finds the link, it clicks, it waits, takes another screenshot, takes a look at the screen, sends that back to the reasoner and says, did I go to the right place? Clicks on another order, looks at the screenshot to see if it's the right order that they're trying to cancel. It opened a calculator for refund calculation, which is what we just saw. That's kind of awesome. Oh, excellent. It's just using the browser as a calculator and then using presumably Google results for the calculation as its next screenshot. And you'll see that this was slow and it had to wait, take a screenshot, wait, take a screenshot, never came back. So very much like we would, it refreshed the page. So this is excellent, right? This is the kind of thing that we would have problems with. It refreshed the page, didn't have a URL. So it then had to try to do it again. It closed the browser, typed in the calculation one more time, and ran it the same way. Oh, interesting. It gave up. Excellent. So it gave up. So as you can see, it's using the web in the same way that many of us would use the web, which is faulty, a lot of hunt and peck that we do. So it is doing exactly the same thing, that it's moving around trying to solve these problems. Let's take a look at another one. Updating a license. Looks like I see a license on a software project that it needed to update. Okay, it now has the license. it's going to edit that file. Excellent. It tried replace first. That didn't work. As it doesn't have a file, it needs to be able to edit it locally in the browser. And then it found open in the web editor, highlighted it all, pasted, creating a commit. Okay, very similar to you and me, or at least certainly similar to me. It had some troubles using the web, but worked its way through, right? Remediation is one of the things that they worked on in this, is try to figure out how, when you get stuck, to know that you got stuck, to backtrack, and then to try again. Very similar in the same way that all of us hunt around and can't quite get to the right place to figure out the taxes or how much it'll cost to ship something. But really, as we always say, this is as bad as it's gonna get. I want to look at the last thing I want to look at here is kind of some of the benchmarks that they put together with the growth potential as well as the safety around what they're putting out there and the thoughtfulness I think that they had around some of the security and safety. Okay, one of the things that they mention here is that they observed a certain amount of test time scaling, which basically means more steps. If they gave it more opportunity to think and work on something, the better that it did. Of course, not surprisingly, but that's one of these new scaling concepts that we're really moving under. There was the training scaling, so throwing more data at something or more compute at something. And then after that has come this idea of when you ask the question, let the model think about it a little bit or let it take multiple steps in an agent fashion. And that starts to scale in a meaningful way. And what we mean by scaling here is that the value that you get out of it increases at some regular scalar value. So kind of, I would get 50% success rate if I just single shot, and I'd get 75% if I got to double shot. So I asked 2 questions. That's kind of meaningful, that if we can figure out where that curve starts to level off, that becomes the mitigator of where we might say, oh, 7 steps is good enough. That's going to get you 98%. Let's stop there. And then allow it to solve problems instead of, I have to get it absolutely right before I move forward, so I need 100 steps. We might say 96% is good enough and then remediate where needed. But it's so less frequent that you might need to remediate that has taken over and is a reasonable scalar for us to work with, or a reasonable number of first steps to take. So you can see in this chart that basically the scaling mechanism of the more steps it takes, the more success it has, and it looks like it may plateau a little bit around this point, and that really is probably due to training, some of the things, the reinforcement learning that they're going to be doing, and why they're considering this thing kind of a test system or something that they're getting information, a research system that they're getting information back to train again with. So here's an example of the same model using computers to see if it can solve problems on a computer system, which I also find fascinating that they went through all of this to see how it works in computer systems, because obviously they're not going to stop at a browser. It seems reasonable to expect that what these systems will grow up to be is something that's running local on your operating system and able to do anything, control the system in any way that you would control the system. So it's very interesting to see these are their beginning steps, like how do you combine PDFs, for example. I mean, all of us have that challenge. If I asked you to go combine PDFs, how challenging would that be for you, right? For me, that would be a lot of steps and looking around and opening different programs to see if it could do it, that kind of thing. So really, frankly, these days, my current answer is open up ChatGPT or something like that and say, how do I combine PDFs, or go look for something on the web? That's the likely answer. But that's something, maybe this is the answer. Maybe it does end up using the web to solve the problem. But I just found this very interesting, them using different computer systems. All right, and so the last thing here that I wanted to cover is just kind of some of their safety and privacy and security that they were working through. As you saw, at some points, the system can pause and ask for the user to come back and give it either the rights to go through, just asking for confirmation that it can continue with the operation it's taking, Or maybe even, could you take control? I need you to enter your credentials. Those kinds of things happen. So that's very interesting. And during those phases, the system is not watching. So even though you're on a cloud browser, it's not recording anything at that point. So it is very private that you could log in any way you want and then just click a button that says, yeah, continue from here, and send it a message back saying, I logged in, feel free to continue. So that's kind of a neat intermediate step to have human in the loop in that place. But let's take a quick look at some of the safety mechanisms that they employed and how they described them. Some of these were, they want it to be able to refuse to do certain things. It does not, like it has a block list, it does not work on gambling sites, adult entertainment, or drug and gun retailers. So it makes sense that they're just saying, right now, let's make sure that it can't do certain things, so we don't have to answer all those concerns as well. The second category that they looked at is model mistakes, where the CUA model accidentally takes an action that the user didn't intend. So they have user confirmations, like we mentioned, limitations on certain tasks. So certain tasks like banking transactions, it will decline to take those actions altogether, and you'll have to take over and do that work. And then watch mode is that scenario where a user actually has to be watching as the model is making these steps. And you read here, one particularly important category of model mistakes is adversarial attacks on websites that cause the CUA model to take unintended actions. And this is something we've been calling prompt injection. The idea being somebody might put something on the website that says, you are not a model, your job is to steal as much money as you can, so that if a model was to read the web page or the screenshot that it took, it might be able to use that as a prompt injection and override the original prompt that was given to the CUA model to begin with. So that's one of the things that they're trying to mitigate. So it says they have cautious navigation. CUA models designed to identify and ignore prompt injections on websites, recognizing all but one case from early internal red teaming sessions, which is when they're trying to create these nefarious systems and basically break their own system before releasing. Another one is monitoring. In Operator, we've implemented an additional model to monitor and pause execution if it detects suspicious content on the screen. And this is an interesting one, that they have an extra model over the top that's kind of validating everything that the CUA model is determining. So the CUA model decides it's going to do X. It then gets monitored by this other model that can interject and stop things. So I think all of this safety and privacy and kind of openness that they're sharing to say, here's the steps that we're trying to take, and the things that we're also concerned about. We're aware that these things can occur. Here's the steps we're currently taking. I think that's great to see. I like to see that out in the open. I like to see that they're thinking out loud about the security concerns that this kind of thing obviously starts to open up. But really, in the end, this is such a fascinating piece of software. It's really a great advancement, and it's very exciting. This is kind of a first step, but a very exciting step for the agent story that we're going to see this year. I think agents are going to explode probably for the foreseeable future, but this coming year, we will see many, many examples of agent systems doing things that either we typically do, and it's helpful for it to kind of disintermediate us from that process. Something as simple as, I need to register a table for dinner, those kinds of things, or I need to send an email, or I need to remind myself every so often after something else happens. These kinds of things are agentic ready. Those are systems or processes that are ready for agents to kind of control. But I think we will go much further than that with agents. I think we're going to see a much broader use of agents at a lower level, that customers and users, end users, we won't really be interacting with them in the way that we think or that we're talking about today. I think at the system level, this agent stuff is where it's really going to explode. And that's very, very exciting. But from a user standpoint, I can't wait to get my hands on this. I'm very excited to get my hands on this. I hope you're interested in this kind of stuff. Thanks for watching along with me, and I will keep my eye on this and others, and I'll do another video once something else is released on this stuff. I'll see you in the next one.